digital sum. Digital sum is defined as sum of the digits. Sum of the digits. If you keep on doing the sum of the digits till a single digit is obtained, digital sum is called as a digital root. But in India, we use digital sum and digital root as synonyms. Whenever I say digital sum, I am referring to digital root. Some important key points. Very, very interesting class, very exciting class where you are going to learn a lot of concepts. Very, very important key points. First key point, what are the mathematical definition of a digital sum? When you divide a number by 9, whatever the remainder that you get, that is defined as the digital sum of a number. If you want the digital sum of a number, divide the number by 9. Whatever the remainder that you get, that is called the digital sum. So if you get a remainder 0, that means the number is perfectly divisible by 0. So digital sum will be 9. When you divide a number by 9, you cannot get remainder 9. So in case if you got 0, adding the digits and telling that the answer as 0, adding the digits, non-zero digits, and telling the answer as 0 is something which probably is funny to hear, but whenever you are getting 0, that meaning is the number is perfectly divisible by 9. If it is perfectly divisible by 9, digital sum will be 9. From this second point, we discussed that digital sum does not only holds good for decimal system. In any base system, it will hold good. Suppose in decimal system, a decimal system is a system where the digits are written in base 10. What is the definition of a digital sum? Definition of a digital sum in decimal system is divided by 9. When you divide a number by 9, whatever the remainder you get, that is the digital sum in a decimal system. Suppose if I take octal system. Octal system is a system where the digits are represented in base 8. In a base system 8, if you divide the number by 7, you will get the digital sum of that number. In a base system n, if you divide the digits by n minus 1, whatever the remainder that you get, that is defined as the digital sum of a number. What is the important key point? In case if you want the digital sum of a number, divide this number by k minus 1 and find the remainder. What is k minus 1? If the numbers are in base system k. Very, very important. Otherwise, you will spend a lot of time in doing the addition and subtraction of a given number. I hope the idea is clear. Digital sum does not even holds good for a decimal system. It holds good for any base system. Digital sum of a number in any base system is the remainder when you divide a number by k minus 1. What is the fourth key point we discussed? 9 multiplied by any number. Answer is a multiple of 9. Answer digital sum will be 9. Suppose 9 added to any number. Answer digital sum will be equivalent to the digital sum of the number which got added. Digital sum of A is equivalent to digital sum of B. Today we are going to solve how it can be used in percentage related problems. 9k we will write. We will write these as K2. This K1. 9k plus A. These are some of the important key points we discussed in session number 1. In case if you are a student watching this session number 2, kindly go back and watch entire session number 1, then watch session number 2. Then it will be much more effective. Digital sum and digital root definition, mathematical definition of a digital sum, reminder when you divide a number by 9, how digital sum can be used for any base system. In a base system 10, it is the remainder when you divide a number by 9. In a base system 8, it is the remainder when you divide a number by 7. In any base system, if you divide the number by k minus 1, that is defined as a digital sum. If you multiply any number by 9, answer digital sum will be 9. If you add a number to any multiples of 9, digital sum of that number which got added will not change. These are some of the important key points which we digital sum application. Digital sum application. Digital sum application. Digital sum application. In number system problems, more specifically simplification related problems, how we can use this concept in simplification related problems. Next, we are going to discuss how to use digital sum problems in percentages and successive percentage related problems. Very, very interesting concept, sir. Successive percentage related problems. We are going to discuss how it can be used in simple interest and compound interest related problems. How it can be used in profit, loss and discount related problems. How it can be used in ratios related problems, ratios relation problems, how it can be used in DI, calculation based DI problems, calculation based DI problems, and some miscellaneous questions which came in previous year examination. At the end of the class, you will get an idea on how to use a digital sum on all these topics. First, we will start with digital sum application in number system related problems, more specifically simplification related problems. Then we will see its application in arithmetic related problems, percentages, successive percentages, simple interest, compound interest, profit, loss and discount, ratios. Then we will discuss calculation based DI problems. Finally, miscellaneous problems. I hope you are all ready for the class. So the heroes of today's class, are the concepts. Today's class are the concepts, not the problems. Each and every problem, I will tell you how the answer option changes, which method you should apply. Heroes of today's class are the concepts. Without wasting time, let us get into the class. First one, I think these also we discussed, base system. First one, all these are over. First one, 88 whole square equivalent to 7544, 7644, 7744, 7834. Now see here. Suppose if I apply, can I use a digital sum of these logic? Definitely I can use. Why? Because the question contains digits. 88 square is 88 into 88. 88 digital sum. 8 plus 8, 16. 16 it is 7. 8 plus 8, 16. It is 7. 7 sevens are 14, 9. 4 plus 9, 13. 1 plus 3, 4. Digital sum for the question is 4. Answer. 7 plus 5, 12. 12 plus 8, 20. It is 2. 13 plus 8, it is 21. 14 plus 8, 22. 2 plus 2, 4. 15 plus 3, 18. 18 plus 4, 22. 2 plus 2, 4. There are two options where the digital sum is matching. Digital sum, left hand side digital sum should match with right hand side digital sum. Should match with right hand side digital sum. Sir, why it should match? It should match because on both the cases, 88 into 88 equivalent to, suppose if I keep 7744, both the sides I am dividing by 9. Both the sides I am dividing by 9. Then applying remainder on both the sides. Then I am applying remainder on both the sides. So I can divide both the sides by 9. 9 will get cancelled. Remainder will get cancelled. So what is that I did? I divided the left hand side by 9, applied remainder. And I divided the right hand side by 9, applied remainder. 9 nines are 81, which is 7. 9 nines are 81, which is 7. 7 into 7 divided by 9. 30, 49 divided by 9. 9 5s are 45, remainder it is 4. That is what I did it here. So anybody who has not understood what I did, I just divided. This is a mathematical way of representation. But we are stuck in two options. Option could be 7744 or 7834 or 7834. Now if you observe 88 square, any number multiplied by itself, any number multiplied by itself, or if any number power is even, then the number is a perfect square. A perfect square will always be of the form 4 into something or 4 into something plus 1. A perfect square will always be of the form 4 into something or 4 into something plus 1. 34. Divisibility rule of 4 is last two digits should be divisible by 4. 34. 4 8s are 32 plus 2. 4k plus 2. 4k plus 2. It is not possible. So option number D is eliminated. Again I am repeating. First I used a digital sum. Digital sum will help me to eliminate incorrect answer options. That means this will tell us which answer options are definitely incorrect. Definitely incorrect. If 3 are incorrect, directly you can go ahead and tick mark the fourth one. If 2 are incorrect, then you have to use some other methods. 88 square is 88 into 88. 88 digital sum is 7. 88 digital sum is 7. 7 7s are 49. 4 plus 9 13. 1 plus 3 4. First option digital sum is not 4. Second option digital sum is not 4. Third it is 4, fourth it is 4. Fourth one, last two digits is 34. 4 8s are 32 plus 2. A perfect square. 88 square is 88 into 88. Any number multiplied by itself, it is a perfect square. A perfect square will always be of the form 4k or 4k plus 1. 34 is 4 into 8 plus 2. That form will not come. Hey Anil sir, what if the options is 7384? What if the option is 7384? There are multiple ways to solve. Method number 2. You can use any method, sir. Method number 2. Use a plus b whole square. If I use a plus b whole square, it is defined as a square plus 2ab plus b square. A square plus 2ab plus b square. 88 square. Listen carefully. Only last two digits pay attention. A square, next is 2ab and next is b square. 2ab and next is b square. 8 square it is 64. 4, 6 carried. 8 8s are 64. 4, 4 2s are 8. 8 plus 6, 10th place should be 4. Again I am repeating. 8 square 64. 4, 6 carried. 8 8s are 64. 4, 4 2s are 8. 8 plus 6, 14. 10th place should be 4. 10th place should be 4. But here the 10th place it is 8. But the 10th place it is 8. So it cannot be the answer. Suppose if the 10th place is 4. 10th place if it is 4. Then if I take 7964. Sir, why this cannot be the answer? 4 plus 4, 8. 8 plus 7, 15. Digital sum is not matching. 14, right? So 14 will be. Let me take it as 5944. I hope you are understanding. Whatever the student who might get a doubt, what if the 10th place is 4? That also I am trying to do. Even if you take 5944 or 6944, 80 square is 6,400. So this cannot be the answer. I hope the idea is clear. So if more than one answer option has the same digital sum, use a perfect square logic. Even if perfect square is unable to eliminate the answer, use a plus b whole square logic. In case if you are still stuck, use the concept to find the square of a number. What is the concept to find the square of a number? A square minus b square. A square minus b square equivalent to a minus b into a plus b. Minus b square, if it comes to the right hand side, a minus b into a plus b. plus b square. This is another concept to find the square of a number. 88 square. 88 is nearer to which number? 100. What is the difference between 88 and 100? 12. So 88 minus 12 into 88 plus 12 plus 12 square. So which is 76 into 100. 12 square is 144. Answer is 7744. Multiple ways to solve the problem, multiple angles to solve the problem, so that when you are solving a problem or whenever you are watching my video, before you are getting a doubt, the doubt I will put it in the board and I will explain it very clearly. That is the beauty of my maths classes. 88 square is 88 into 88. 7 sevens are 49. 4 plus 9, 13. Digital sum should be 4. 1 and 2 out. Third and fourth are there. Fourth one, it is out. 2 square will always be of the form 4k or 4k plus 1. 34, it is out. Even if it is of the form 4k plus 1, apply the tens place logic, 2ab b square. Still, if it is not giving an answer, you can go the method how to find the square of a number. Introductory problem, I hope it is very, very clear. First one. Second one, 73 whole square. 73 whole square. The first thing which you should do is 73 square is 73 into 73. Any number multiplied by itself. Any number multiplied by itself, it is a perfect square. Either it will be of the form 4 into something or 4 into something plus 1. Either it should be of the form 4k or 4k plus 1. It is 4 into 9 plus 3. It cannot be the answer. These eliminated. Tens place 2, 2, 2, 2, 2. 3 places, tens place it is there. 4k or 4k plus 1. Apply digital sum logic. If I apply digital sum logic, now see here, 73 into 73, 7 plus 3, 10, 7 plus 3, 10, 1 ones are 1. Answer digital sum should be 1. Answer digital sum should be 1. 9 deleted. 5 plus 1 plus 2, 8, not possible. 5 plus 2 plus 2, deleted. 5 plus 4, 9 deleted. 5, 1, 4, 9, it is 1. 9 deleted. 5 plus 3 plus 2, 10, it is 1. So we are stuck between option number C and option number E. I hope it is clear, right? Digital sum helps us to eliminate A, B and D. Now what is the logic? You can use a tens digit logic. A plus B whole square is. You don't need to write it, just for reference I am writing everything in detail. A plus B whole square is A square plus 2AB plus B square. I want tens place. So 2 into 7 into 3 slash 3 square. 3 square it is 9. 2 sevens are 14. 4 threes are 12. Tens place should be 2. Tens place should be 2. Tens place is 4. It is eliminated. So answer for this question is option number C. Answer for this question is option number C. I hope the idea is clear. First is a digital sum logic. Then it is perfect square logic. Then even if you are stuck between both, then you can go by the tens place logic. Tens place logic. Now if you observe, there is an cat level question which probably I will discuss it in perfect squares. ABCD, it is a 4-digit perfect square. ABCD, it is a 4-digit perfect square. AB is a prime number. First 2 digits it is a prime number. And CD is also a prime number. And CD is also a prime number. One such number is 73 whole square is 5329. 53 is a prime number, and 29 is also a prime number. 5329 is a 4-digit perfect square where the first 2 digits is a prime number and the next 2 digits is also a prime number. We will discuss this question in detail in perfect squares. Another concept is 77 whole square is 5929. This is also another number. 59 is a prime number and 29 is a prime number. 73 is one such 2-digit number which itself is a prime number On squaring, I got another 4-digit number where the first 2 digits is a prime number and the next 2 digits is also a prime number. So how many 2-digit prime numbers are there? On squaring, I'll get another 4-digit number, perfect square, where the first 2 digits is a prime number and the next 2 digits is a prime number. This is one such classical example. Second question, introductory question. I hope the idea is clear. Which each and every concept, you will understand it in detail. Now see here, 14 cube. First, if you apply digital sum logic, step by step, problem by problem, my student will learn all the concepts, digital sum concept. Suppose if I go by the digital sum concept, 14 into 14. 14, what is the digital sum of 14? 5. Here also it is 5. Here also it is 5. 5, 5, 5. 125. 125 digital sum is 8. 125 digital sum is 8. Answer digital sum should be 8. Answer digital sum should be 8. 2 plus 7, 9. 4 plus 4, 8. Matching. 4 plus 3, 7. 7 plus 2, 9. 8. It is also matching. 7 plus 2. It is also matching. These not matching. These are not matching. Option A and B, only 2 options got eliminated because of digital sum. Option C, option D and option E. All 3 of them are giving you the same digital sum. Now if you observe closely, what are the last 2 digits of 2744? 44. 2834, 34. 2474, 74. 3 options digital sum is matching. All the 3 options last 2 digits are different. So let me attack it by using last 2 digits. Whenever you are solving a problem, you will get your own idea just by looking at the answer options. 14 into 14 into 14. 14s are 196 into 14. Last 2 digits if I am doing 96 into 14. 96 divided by 100 minus 14 into 14 minus 56. Negative remainder 50 is minus 56. Positive remainder 44. So this cannot be the answer. 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 I hope the idea it is clear. 96 into 14 minus 4 into 14. Why, from where you got minus 4? 96 divided by 100. 100 ones are 100. Negative remainder minus 4. Minus 4 into 14 is minus 56. Positive remainder is 44. Idea clear? Now, suppose if the question is 1844. 1844. 12 cube is 1728. 13 cube is 2197. 1844. Suppose if the option is 1844, then what you can do is, you can do by using a plus b whole cube logic. Already we discussed in our speed calculation class. Whenever we are stuck in any problem, the concepts which we discussed in speed calculation will help us to find the exact answer. 14 cube is a is 1 and b is 4. A cube, 3a square b and 3ab square and b cube. If you solve this, you will get 2744. 1 cube is 1. 3 4s are 12. 16 3s are 48. 4 cube is 64. Write down 4. 6 carried. 4. 5 carried. 17. 2744. If you are stuck, you can use this concept is used at the last step. First go by the digital sum concept. If 3 incorrect answer options are there, then stop it there. Or if you are able to eliminate if you are able to eliminate only few, then use the last 2 digits logic. Then in case if you are still stuck, go and use this logic. Complete comprehensive understanding of digital sum concept in detail. We are going to discuss the digital sum concept in detail. 14 it is 5, 5, 5, 5. 125 it is 8. Three options got digital sum 8. All the three option last two digits are different. So I attacked by using the last two digits logic. 14, 14, 14. 14 14s are 196. Last two digits is 96 into 14. 96 divided by 14. 100, which is minus 4. Minus 4 into 14 is minus 56. Pause, last two digits it is 44. Idea clear?